Good morning. My name is Jirash Ramnath. I'll be today presenting a new capital investment project or processing facility for converting banana stem into clothing yarn. This is a joint project between myself, Hayden Hebert, and Kenny Luis Rodriguez Suarez. The presentation will cover the project overview, technology overview, market and competition, sustainability, and financial project investment needs. The project overview will be presented by myself. For material we have researched, we have found that it is more feasible to have this project, a new facility located at St. Mary's in Jamaica. And from research, we have found out that within that area, the potential for producing dry fiber yarn from the banana stem turn around between 17 to 34 tons per day. The technology for the conversion of banana pseudostem or stem into spinning yarn or yarn for clothing is a very straightforward process, and it's a very simple process. Basically, the banana stem are harvested from the field and transported to the processing facility where the fiber is separated mechanically. The separated fiber still do contain gum which bind the fiber together and then which need to be washed away. This is a material which will basically contaminate our end product. The washed fiber is then dried, and after drying, the fiber are spun into yarn using simple machinery. Like I said, the banana stem will be harvested from the field, and this is a manual labor intensive process. These banana stem will be transported through trucks to the processing facility. At the processing facility, we will have warehouse to store the raw material, and after that, the banana stem will be processed into the fiber or yarn. The mechanical separation of the fiber from the stem is carried out using a simplified machinery as shown in the picture here. The process basically involves pressing the water out and stripping the fiber from the stem. The washing and degumming is done using sodium hydroxide. The degumming process removes all the gum, residual gum, which stays with the fiber after the mechanical separation. The washed and degummed fiber is then sun-dried in open air, and this process can take between 72 to 94 hours. And here we have we show one of the machinery which can be used to spin the banana fiber into the yarn, which is the final product of this processing facility. Now I will yield the floor to my colleague to present the rest of the project. Thank you very much.
Hello, everyone. My name is Kenny Rodriguez. I'll be presenting on the market and financial analysis for our banana textile project. So banana stalk is a raw material that is widely available, and it's used to make textiles, paper substitutes, building materials, and other handicrafts. So for our project, there were several advantages that we could pinpoint. One being the fact that the raw material is available and untapped, so it's currently burnt and disposed. It comes from a sustainable material, so we can market to environmentally conscious consumers and brands. It's a relatively simple and labor-intensive process. However, the fact that we included machinery allows us to get a higher return on our investments than if it were manual processing. In terms of disadvantages, the fact that finer quality yarn and textiles require more complex and more expensive machinery, it's a disadvantage for us currently. And there is no local market at the moment, so we'll focus on developing the local market before we can, and establish a local market before we decide to export. The opportunity is a tremendous opportunity, really, because we have the raw material. There's nobody else that does it here, and we're very close to the largest consumers, which are in North America. Threats to the project include the fact that there's a lack of awareness of this market, as well as other competing fibers that people are more aware of here and internationally. And the fact that banana is a seasonal commodity, so we may have some issues with the availability of raw material seasonally. So the market is growing. It's expected to be worth around $1 trillion, sorry, by 2034. The largest producers are in South America and Asia. However, Jamaica has some incentives in regards to its location, first of all, as well as the circular economy initiative from the local government. So that's what we're trying to exploit. Currently, these fibers are priced between 12 and 25 US dollars. We plan to sell it at $12 per kilo, which will allow us to be a little bit more aggressive in the market. Some of the more recognized or international brands that use these types of fibers are Zara, Tom, Lucy, and Yak. However, locally we have Apparel Warehouse and Crimson Dawn, which manufacture for hotels and memorabilia shops, so it allows us to give that touch of providing a local commodity for tourists.
Hi, I'm Hayden Hebert, and I will be presenting sustainability aspects of the technology of the business venture we are talking about today. And so, the environmental impact of other textile materials cause water and soil pollution by releasing chemicals into the environment and contribute to 22 to 43% of landfill waste and 6 to 7% of total ocean pollution. The textile materials produced by these processes are toxic and non-biodegradable and can contribute to local droughts by using over 93 billion cubic meters of water annually and also producing 1.2 billion tons of greenhouse gases annually. Other natural fibers from plants and animals also sometimes rely on pesticides and chemical fertilizers, and through their cultivation can actually damage the local environments. The technology proposed reproduces banana pseudostems, reducing landfill waste and producing environmentally friendly, non-toxic, high-tensile, and soft fibers for clothing and woven items that are biodegradable at cost-effective prices for local communities. Using pseudostem also provides farmers an extra income stream, which may lead to cheaper produce for local communities. So just by integrating 15% of banana fiber into polyester resin can meaningfully reduce its emissions. Untreated banana fiber with kaolinite also shows the lowest overall emissions impact with roughly a 25% reduction compared to just polyester resin. The 15% banana fiber and the untreated banana fiber with kaolinite overall showed the lowest impact among all three categories, that being human health, ecosystems, and resource consumption. However, treating banana fiber also drastically increased all markers as compared to just regular polyester resin. Fabricating either 15% untreated banana fiber or untreated banana fiber with kaolinite, depending on sustainability goals from our plant, will have a positive impact for a more sustainable future.
So continuing on with our financial analysis, we want to explore the cost it would take to produce these banana textiles. So we'll explore the fixed and variable costs as well as the total cost and the benefit cost ratio, the break-even analysis, and the return on investments, as well as a breakdown of the loan payments. So this is a breakdown of the fixed and variable cost as a dollar value per year in US. This is a percentage of the fixed cost, a breakdown of the percentage of the fixed cost and the variable cost, as well as the total cost of the project per year. These are the formulas that we use to calculate the BCR, BEP, and ROI. So basically, what this is telling us, our benefit cost ratio is telling us that for every dollar that we spend, we are able to earn $1.30. So to cover all of our overhead costs, we would have to sell only half, or around 3 metric tons of our total yearly production. And we can get a return on investments of 30% for this business, which is highly lucrative comparing to other markets. The necessary capital to start the business would initially be 51,000 US dollars, which will get us a bank loan at 12% over 5 years. And here's a breakdown of the payments yearly. Thank you very much.